Hello ladies and gentlemen, Mr. Lang here. I'm going to take you through the chapter 3 pretest. Starting with number 1, x is greater than or equal to 2. We are looking for numbers that would make this true. Greater than or equal to 2, so we could be equal to, so we would do a closed circle, or anything greater than 2, which would be to the right. Number 2, write an inequality shown by the graph below. Well, remember the graph is graphing x, what would be true, so x is less than negative 4, so I'm going to write it just like I say it, less than negative 4. It is not equal to, so I do not include the line underneath. Number 3, to join the cross-country team, runners must be able to run a mile in no more than 9 minutes. So if you are running more than 9 minutes, you are not qualifying for the team. So you can be no more than 9 minutes. So if I think about that another way, that means the minutes have to be less than or equal to 9. I could be exactly 9 or any race time below 9 minutes per mile. So it says write an inequality. There it is. Graph the inequality. Now here's what's a little bit difficult is 9 is not on the graph, so I need to put a 9 there. It could be equal to 9 and it could be less than. However, it's not physically possible to go back in time or have negative time. So we need to stop at 0 and do an open circle because we also cannot run a mile in 0 seconds. It would be impossible. In reality, from 0 to 4 would be nearly impossible, but that's the options for time there on number 3. Number 4, solve and graph the inequality. All right, I can do that. When I add, I like to use blue, so I'm going to add 1 to both sides, and that leaves me with C is less than or equal to 4. So I could be equal to 4, so I'm going to fill it in, or less than or equal to 4, so any number lower than that. Brian has a gift card. So far he has selected a shirt that costs $52. Well, he's got $75 to spend and he's already spent $52. I'm sure we could all figure out how much money he has left, but he doesn't really need to spend all of that money. So his unspent money, let's call that S, plus the money he's already spent, $52, has to be less than or equal to the $75 he has available. Alright, so that would kind of be my original problem, original setup. And then my answer would be just, of course, to subtract the 52 from both sides. And we would get S is less than or equal to $23. So it could be exactly $23, so that would be somewhere in here. We do a closed circle. Now, if we're talking about gift card, you can't go below 0 on a gift card. You could have exactly $0 left over, so we'll stop at 0 there. Moving on, number 6, solve this inequality and graph. Notice in this learning target 3, it says I can recognize when to flip or keep the inequality. Alright, so I need to watch out for multiplying or dividing a negative to both sides. Well, on this first one, I'm just going to rewrite the problem. 3/4 x is greater than 3. And to cancel out a fraction, I'm going to multiply by the reciprocal, which would cancel both the 4's and the 3's. However, I also have to do that to this side. And to multiply 3 by 4 over 3, I'm going to think 3 over 1. Alright, and then I'm going to multiply straight across, which is nice about fractions. So I'll be left with x is greater than or equal to 12 over 3. And 12 divided by 3 is, of course, simplifies down to 4. So I get 12 is greater than, x is greater than 4. So not equal to 4, but any numbers that are greater than 4. Alright, I can already see it right here. I have this negative 4m. So when I'm going to get m by itself, I'm going to have to divide by a negative 4. and divide by -4. Here's where the alarm needs to go off in your mind. And be aware that you're needing to flip that symbol because you are dividing by a negative to both sides. And so first thing I write down, I'm going to write down my flip symbol going the opposite direction, and that would leave me with m is less than or equal to -3. So I'm going to come here to -3. It could be equal to, so we're going to do a closed circle, and then anything below. Alright, number 8, we have a t-shirt question yet again. Pretty decent profit, $2.50 a shirt. The question is, how much must they sell to make at least $200? So they'd be happy to make more than $200. But the question is, how many t-shirts would they need to make 200? But again, they'd be happy to go over. So we know that it's $2.50 profit for every t-shirt. And that profit, the goal is to have it be greater than or equal to $200. Okay, so the t-shirt money, the profits can be over $200. Alright, well then when I come in and divide both sides by 2.50, divide by 2.50, you get an answer is the t-shirts are greater than or equal to 80 t-shirts. So they can buy somewhere in here 80 t-shirts exactly, or they could buy more. Now technically this is a tough graph, is because you can't buy part of a t-shirt, so it should technically be a dotted graph. However, it would take a long time to dot those graphs, so we would accept both. But we should write it actually should be dotted. And again, the fancy word for that is discrete, but for the sake of time, we're not going to dot that one. Number 9, solve and graph multi-step. So I know I'll probably have some simplifying, some combining like terms. Key thing is to always put a line down that symbol so you know what's on the same side. So actually I end up with 12x minus 24 plus 2x is less than or equal to 4. So I do end up with some like terms on the same side, so I need to combine those. Positive 12 and add 2 more, that would equal 14x minus 24 is less than or equal to 4. So finally I can add my 24 to both sides. I'm left with 14x is less than or equal to 28. And then divide by 14, divide by 14. I'm left with my final answer, x is less than or equal to 2. So could be equal to 2 or anything less. Right. Moving on to number 10. I can write, solve, and graph inequalities with variables on both sides. So keyword, key noticing, I know my letters are on both sides, my variables. I always choose to subtract the smaller variable from each side first. It just helps me avoid having to deal with negatives. So then I'd be left with 5y minus 2. And then just add that 2 over to the other side. Move to the side here, I'd have 5y is greater than 5. So then I would divide both sides by 5. Actually, both divide out to equal 1, so I'd have 1y on the other side. So I'd have 1 is less than y. I'm going to write that on my answer line. So if 1 is smaller than what y is, well, that would mean y is then bigger than that 1. So to graph y on the number line, I cannot equal to 1, but I'm greater, so I would go to the right. On number 11, this is a great comparison one. So I can already tell I'm going to be comparing two businesses or schools, or in this case it's field trips. So we're comparing the Ford Museum to the Art Museum. So if it were me, I'm just going to keep track. I'm going to put the art situation over here. and the forward situation over here, and then just kind of figure out my problem. So starting with Ford on the right, the Ford Museum charges $80 plus $5 per student. So extra $5 for every student. So I know they're $80 plus $5 for every student. And the Art Museum just charges $7 per student. So they don't have an extra fee. They just are a little bit more expensive per student. And then finally my question says, for how many students will the Ford Museum charge less than the Art Museum? So that means the art is greater than the Ford and not equal to. So I have my setup. I have my S on both sides. I'm just going to subtract 5S. Subtract 5S. And that would leave me with 2S is greater than 80. Pretty quick math, can already divide by 2, and so I would be left with my final answer as the students would have to be greater than 40 students. So what does that answer really actually mean? So if S is talking about students, in words I could say something like, if there are over 40 students, then Ford is the cheaper option. Okay. In the end here, the final learning target 6, are compound inequalities. What's nice is the skill remains the same, it's just we have to do it, if it's one of these combined and inequalities, we have to do it to all 3 sides. So just like normally we'd add 5 to both sides, well now we're going to add 5 to all 3 sides. So that would be 6 is less than or equal to 2n, which is less than or equal to 12. And then just come in here and divide by 2 and divide by 2. And we're left with n in the middle. So it's less than or equal to the bigger number, but it's greater than the smaller number. 3 and 6. And what's nice about graphing these, they're both equal to. So it's equal to 3, it's equal to 6, and it can literally be any number in between those two numbers. Alright, this last one, notice how these are going the opposite direction. So if I think about this number line right here, going that way, that's x, or it could be going this way. So basically it just cannot be 6 or any of the decimals in between 5 and 7. So it's smaller than 5 but not equal to 5, or bigger than 7 but not equal to 7. Well, I just write them as 2 separate. So x is less than 5, or x is greater than 7. And it's not equal because both have an empty circle. Hopefully the pretest went well for you. Just a quick little summary through. And we look forward to you having a successful Chapter 3 test. Thanks, everyone.